All right, so we're going to learn about trig definitions, the unit circle, stuff like that. Just really basic stuff about trig functions. Okay, we're going to use this with just regular numbers, not using calculators. The theory is you kind of get used to it without a calculator, then you can do it with a calculator, and then you're super awesome at everything. So just basic stuff. If you have a single angle, wherever it is, then anything that's opposite the angle is called the opposite side. And then the longest side of the triangle is the hypotenuse, and then the remaining one is the adjacent. So again, any kind of triangle that I give you, if I label this one, you have opposite, and then the longest one is the hypotenuse, and so the extra one is the adjacent. So again, no matter how I draw it, I can't possibly draw anything more complicated than this, apparently. I'm going to try to draw it like, look, I'm going to put this way up here and see, even if I draw something that doesn't even look like a right triangle, if I just pretend it is, opposite. And the hypotenuse is the one that's across from the right triangle. And this is the adjacent. So opposite, hypotenuse, and adjacent. Now, if you've taken math classes, a lot of times they call them like, whenever you're learning sine, cosine, and tangent, they call them like x, y's, and z's. Not z's, x, y's, and r's. And that's because in math, you're always measuring from the positive x-axis in a counterclockwise direction. But in engineering and other stuff, you don't necessarily do that. Kind of just depends, because in real life, you might be out in the field and you're going to measure an angle from here or wherever. So I prefer for people to not learn the X, Y, whatever is fine for a math class, but for like engineering classes, I say that it's really better to learn the concepts of opposite and adjacent, because then no matter what unit system or coordinate system you're in and what you're measuring from and what direction theta is going, opposite, adjacent, hypotenuse always work. Okay, so for example, if you have these, just to kind of look, make sure you know which one is which. So pause the video, try it, just make sure you got it. Burps. Look at this. Look at that amazing, what do you call that? Animation. I'm kind of a genius. And adjacent, okay, because it's the one adjacent. Yay! Okay. So sine, cosine, and tangent. So sine is the definition of the ratio of the opposite side to the hypotenuse side. So basically, if I take this triangle and I make it tiny, or if I make it big, or anywhere in between, the ratio of this side and this side is always going to be the same. In fact, the ratio of any of the two sets of sides together is always going to be the same. And that's why we care about sine, cosines, and tangents, is again, if I have a triangle, any side to the other side, the ratios are always going to be the same. So this over this is the same thing as this over this. So that's why we care. And so basically a long time ago, we realized that those ratios are all the same. So if you know what the ratio is, you know what the angle is, right? Because the bigger the ratio, the bigger the angle, right? The bigger, if this is a big opposite, if opposite is really big compared to the hypotenuse, then it's a bigger angle. And you could go look that up in a table. So we'll talk about that in a while. But for the moment, let's just memorize what the ratios are called. And they're completely arbitrary names. And the way that we set them up is kind of sort of arbitrary-ish. So it's just the way it is, I guess. I don't have a better way to say it. Now, I know that in high school they'll tell you something like, hold on, I'm trying to spell it, SOHCAHTOA, but I can never remember how to spell it. The only way I can spell it is if I actually go sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, over, adjacent. So you could do that. I had a student one time, which I thought was pretty awesome, taught me another mnemonic device, which is some old hippie caught another hippie tripping on acid. So that should also be a way to remember, and I can always remember that because it makes me giggle. So some old hippie caught another hippie tripping on acid. And for some reason in my silly brain, I always thought that TOAD spelled toad, and for some reason I always spell tangent as toad. But some old hippie caught another hippie tripping on acid. Get you sine, cosine, and tangent. Isn't that fantastic? Okay. These are things you just have to have memorized. It can't be something that you're looking up. It's like knowing the alphabet. You know, you just gotta know it. Okay. So we've had other videos where we're like, it's really important to memorize your special triangles and blah, 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 blah. So basically, like if we had a triangle that was 30 degrees and this side was 1, well, then you'd know that this side is 2 and this side is square root of 3, right? So if I was going to go do the sine of 30, the sine is opposite, which is 1, over hypotenuse, which is 2. I guess I should have started with cosine. I'll start with cosine. But anyway, I've already got it written. I'm too lazy to erase it. Cosine 30 is adjacent over hypotenuse, so that's the adjacent side. And the tangent of 30, toad, is opposite over adjacent, which is square root of 3 over 3. That's not on this chart, but essentially, sometimes I guess what I'm saying is sometimes you see this chart. I don't like this chart as much, but some people do. But these are in the order of cosine, sine, and that's because the cosine is like the x one and the sine is the y one, if you're thinking about it in terms of x and y. So this would be the cosine of 45, and then the sine of 45. And this is the cosine of 60 and the sine of 60 and the cosine of 9. I don't read it this way in my brain, so I know this is my slide, but I think everyone else learns it this way. So I try to teach it this way. Go back. I try to teach it this way because I feel like that's how everyone else learns it. But I'll show you the way that I did it for some reason. So I literally just, whenever I was doing this, I guess I could put these in as actual 30s. So if you know the sine and cosine, then the other thing that I guess we kind of skipped over, but you probably know already at this point, is that the tangent of something is the sine over the cosine. And my thing's being weird. Is sine divided by cosine. So if you know the sine and the cosine, then you can find, why is it being so silly? Then you can find the tangent. I'm going to be dead honest as opposed to all the lying that I've been doing so far with you guys. Let's see. I'll just kind of go over here. I just learned for 30, I kind of learned a sine, cosine, tangent pairs. So for 30 degrees, I just memorized that it's 1/2 square root of 3 over 2 and square root of 3 over 3. I learned for 45, it's root 2 over 2, root 2 over 2, and 1. For 60, I learned that it's, hold on, let me make a little bit more space for myself. For 60, I learned that it's the kind of flippy flip on the 30. It's root 3 over 2, 1/2, and square root of 3. For 90, I'm just going to run out of room over here. I'll just do it over here. For 90 degrees, actually, I'll do 0 and 90. So for 0, it's 0, 1, 0. And for 90 degrees, it's 1, 0, and then undefined, because it's 1 over 0. So undefined. So I just, for some reason in my brain, it made more sense. Because I'm not a picture learner. I'm a list learner. So when I was learning lists, I learned better with these kinds of lists, this direction, because then I can just look at the table and kind of see patterns and being like, okay, I kind of see where that is. So if you're more of a pattern learner, then this might make more sense. Even with 90, I just, for some reason, because I pictured it being at 90 and it was 1, 0, undefined, but in my heart, in my mind, because I was in high school, I made that into a heart. And so I'm like sine, cosine, tangent, and it just made me smile. Anyway, however it makes sense for you to learn these, and I've had students that'll be like, so what you do is you like have this 3 here that goes with this 3 that goes with this 3, and then I don't know, but they like had this whole story that somebody had taught them, and I was like, okay, dude, like whatever, but apparently it's a thing. So if you have a way that makes sense for you, keep doing it. If you don't have a way that works, find one, or just make yourself flashcards on like Quizlet or something, or download pre-existing Quizlet cards. But these are the kinds of things that you're absolutely going to have memorized: sine, cosine, and tangent. Definitely at the first quadrant of 0, 30, 45, 60, and 90. And again, not because of any reason except that traditionally these were ones that people just kind of knew off the top of their head, because before you had access to calculators and when you had slide rules, you have to kind of like estimate off the top of your head. If you know the sine of 30 is basically 1/2, and it's not basically 1/2, it's exactly 1/2, and dip-de-dip-de-doo. So trig values to memorize, these are the ones that you're going to need. So if this picture makes sense to you, great, and just go ahead and brag about it, but yeah, I don't get it. Okay, so generally, the idea is without a calculator, could you find the sine, cosine, and tangent of these? So we would kind of go through and say like, okay, so we have whatever we want this to be. So let's call that just unknown. So I've got x squared plus 4 squared equals 8. I was already going to write 64, but I'll say 8 squared. So I've got x squared plus 16 equals 64. This is where I'm going to do the dumb math. Hold on. I'm going to go off to the side because apparently I can't do... Whoa. What just happened? I have no idea. Ah! I mathed myself into a weird... Or I did something weird. I don't know what I did. Math. Make it stop. There we go. Doop-de-doop-de-doo. That was fun. Just to fix that one stupid 6. My eraser isn't working on my pen. So, look at this. I'm like 12 years old trying to do math. Okay, so x squared is 48. So x is square root of 48. So what is that? 4 times 12, which is 16 times 3. So that's 4 square root of 3. There we go. Okay, I know I was going to get there eventually. Oh, because it's 1, 2 square root of 3. I'm the dumbest, probably, ever. Yep. See, I'll bet you when I was doing this, I was like, I'm going to put this here so it'll be really easy. Well, hot potato. Since it's 1, 2 square root of 3, now what do I know about this? I know that this is a 30-degree triangle, because I'm kind of a genius, right? Yay! So, like this is 1 times 4, this is 2 times 4, and this is square root of 3 times 4. So this is a 30, 60, 90 triangle. Look at me doing all kinds of extra work for no reason. Okay, so the sine of theta in this case is going to be opposite over hypotenuse, which is going to be 4 over 8, which is 1/2, which makes sense because it's 30, and I happen to know that the sine of 30 is 1/2 because I had to memorize it, and so do you. Yay! Okay, cosine of theta is adjacent over hypotenuse, which is the adjacent side. Remember, it's the one that's not opposite. So 4 square root of 3 over the hypotenuse, which is 8, so that's square root of 3 over 2. And again, can confirm the cosine of 30 is square root of 3 over 2, just because we know that. And then the tangent, this better come out as square root of 3 over 3, is opposite over adjacent. So the opposite side is 4. Why do you do that to me? There we go. 4 over the adjacent side, square root of 3. So that's 1 over the square root of 3, which is indeed the square root of 3 over 3. And yes, I do happen to have memorized that the tangent of 30 is the square root of 3 over 3. Look at me. I'm kind of a genius. So that checks out. I'm not saying that you had to have this checky marky ones memorized now, but that's kind of the idea, is that once I recognized it was a 1, 2, square root of 3, I could have just been done with the problem. But, you know, that was the fun part, is doing all the math. So that was great. Okay. So let's do this again. 3, 4, no, 3, 5. No, it's because I was going to say this is a 3, 4, 5, but it's not, because this is if this is a 3 and this is a 5, that can't be a 4. So that's not going to work. So, so I've actually got to do the math here. So let's see. So again, this is going to be my C thingy. So I've got 6 squared plus 10 squared equals C squared. So it's 136 equals C squared. And goodness, what's 136 divided by 2? Some kind of number with a 7 in it, like a 78. Hold on. You'd think that I would work these out in advance, and I probably did at some point, but, you know, 68. Oh, goodness. I'm kind of a genius. You may have not picked up on this. So if I divide that by 2 again, I'll get 34. So C equals the square root of 4 times 34, and 34 only goes into 4 and 17. So that's 2 square root of 34. Well, that certainly isn't a pretty answer. That's fine. But now I've got stuff to do. So sine of theta. And remember, we're not using a calculator intentionally, because right now we're just practicing using trig functions. So now that we've done that, I would recommend pausing the video and seeing how far that you can get before I talk myself into the wrong answer. But pause the video, see how far you can get. If this is the first time you've really gotten used to using trig functions, I can't spell. I would say start by just writing all these down, and write it over and over and over. Don't just go in your notes and start writing down the numbers. Write the definitions, so that you just get used to it. So every time you write it down, it's just one more chance that you have to memorize and learn it. Okay, so opposite from the theta is the 6. The hypotenuse is apparently 2 root 34, because I hate myself. So that's 3. I'll change colors there for funsies. 3. Okay, that was fun. And totally worth the extra second it took to do that. So we'll go 3 root 34 over 4. 34. That was great. Adjacent is going to be 10 over 2 root 34. So that's 5 root 34 over 34. And opposite over adjacent, opposite is 6 over 10, so that's 3. That's beautiful. Gotta love it. That was fantastic. And again, these are things that you can eventually throw into a calculator to get the actual value of theta, because this is the same. And that's, hopefully now you can see what we're saying. So like if I just schnooked this down to this, where this side was 3 and 5, the tangent of theta would be the same theta, and it would still be, that ratio would still be 3/5. So I'm getting the same angle, as long as the triangle is proportional, I guess. And that's why trig functions are really cool, is they're looking at the proportions, they're looking at the ratios of those dilly bops, at the ratios of those sides. And that's kind of why you're able to use them. So whenever people first started discovering this mathematically, they were like, holy jamalama, we can do all kinds of cool math with this. So it's kind of neat. Okay, similarly, We could use trig functions and the stuff that we have memorized to do this. So now also we could be like, okay, well, it's 30, 60, 90. Okay, so I'm going to do it the easy way, and then I'll show you the complicated way to do it. But we'll say, okay, well, it's a 30, 60, 90, so that's an 8. This is 8, because this is the 30 side, right? So that's 8 square root of 1, 2 square root of 3, so this is 16. Okay, that's the answer. But let's go ahead and solve it using trig, just for funsies. So, so we know what answers we're supposed to get, but we'll go ahead and run through this just to see how we would do it. Okay, so say we have the sine of 60 is going to be the opposite over the hypotenuse, which doesn't do us any good right now because we don't know either of those. The cosine of 60 is going to be the adjacent over the hypotenuse, which we can do. So the cosine is 60, we know the adjacent is 8, the hypotenuse is r, and by the definition of cosine of 60, we know that that's 1/2, okay, because we can look that up in a table, for example. I'm just trying to say, pretend you don't have a calculator. And this is back in, 1827 or something. We're trying to solve these problems because the internet went out. Okay, so essentially what we have is we have 1/2 is equal to 8 over r, cross multiply, or however you want to solve that. That gives you that r is equal to 16. Wait, I totally did that wrong. See, this is why I shouldn't be in charge of anything ever, because I just totally labeled it wrong. That's what I wanted. Ah! Okay, oh, yeah. Okay, so I'll fix that. But clearly I make mistakes. So that is the answer I wanted. It's a good thing I worked it out a second time because clearly I'm an idiot. All right, let's try the next part. All right, so let's go with tangent. Being dumb is so hard because it makes you have to do extra work. Opposite over adjacent. Okay, so in this case, the opposite would have been an unknown value, x, and the adjacent is 8, but I would know that the tangent of 60 degrees was the square root of 3. So the square root of 3 is equal to 8 over x, so x is 8 square root of 3. And that, yes, is what it was actually supposed to be. So that was embarrassing, but good to know. See how you do stuff, and it's fantastic. But that's how you would use trig functions to solve for values, like if you didn't actually know what they were. All right, let's do this again. 24, 25. Okay, so here's another opportunity for me to try to redeem myself. So this is a Pythagorean triple. So rather than doing the a squared plus 24 squared equals 25 squared, I can just be like, that's a 7, and I'm a genius now. Okay, so sine of theta. Oops. So again, try and pause the videos on these when we're working through them and see how you can do on your own, because that's important. Because, I mean, some people just like to watch and then kind of work through them separately, but it's up to you. Do what makes you happy. Opposite over hypotenuse. So opposite of this dude is 24. And let me make sure I didn't do something stupid, right? Because that's the longest one, right? 25? Okay, that's definitely the hypotenuse. It just is clearly not to scale because it just freaking me out because that's obviously shorter than the 7, but it's fine. 7, opposite over hypotenuse is 25, so that's all we're looking for there. Cosine of theta is adjacent over hypotenuse, so the adjacent side is the 7, and the hypotenuse is still 25. And then the tangent of theta is the opposite over the adjacent. Opposite is 24, and the adjacent is 7. Beautiful. Now, I don't know what else you would want to do with your free time besides problems like these for like all eternity, so it's pretty amazing. 24 over 7. So, let's see. Okay, this, maybe if you take a look at it, you can see a pattern. This is a 3, 4, 5, right? Because I've got a 3, 4, 5. 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10. So that's my missing side. And I can do that. Now it's trying to tell me to find the missing angles. Okay, so I'm just going to get everything in terms of sines and cosines and stuff like that. So 3, 4, 5. And I think I put this in here because I wanted you guys to recognize that a 3, 4, 5 is not a 30, 60, 90. So I've got the sine of theta is equal to opposite, which, or I'm going to go ahead and write it out. Opposite over hypotenuse, which is going to be, what is that number? 8 over 10. And I'm just going to write these out. We're not actually going to find the value of theta. But we could, if we had a calculator, we could throw these in too, but we're not going to do that. Adjacent over hypotenuse is 6 over 10. I guess 4/5. 3/5. Tangent theta, opposite over adjacent, which gets you something like 8/10. No, math is hard. Adjacent is 6. I do that a lot. Adjacent is 6. 4/3. Now, if you were to put this into a calculator, you get theta is about 37-ish degrees, I think. Might be 33, 37-ish. It's more than 30. But that's kind of the point, is that it's not exactly a 30-degree angle, remember, because the sine of 30 degrees is 1/2. This is 4/5. So this is, quote unquote, clearly not a 30-degree angle, because that's just not what it is. And it's not a 60-degree angle either, because the sine of 60 would be 1/2 and this is 3/5. So it's kind of on a little bit of both. So that's not a 30-degree angle. Let's see, is there anything else we could do? No, I think I'm pretty happy with that. Okay, let's see. Okay, well, again, we just worked this problem. Good. I'm not going to work it again because that would be silly. Okay, let's do this again. Now without a calculator. Okay, this would just be another example. So sometimes you're going to see this little button on your calculator. Picture will look like this. This is called an arc sine. Arc cosine and arc tangent. That's one way to do it. Another way that people say it would be inverse sine, inverse cosine, and inverse tangent. Okay, so basically it means the opposite. Like undo this. So inverse in math, except with an E on it, means undo the. So like if I say the inverse of 3, hold on, the inverse of 3 is, if I want to undo if the inverse of like times 3 is divided by 3. So like if I have 3x, then like 3x equals, 12, then I multiply by the inverse, and then I get x equals 4. I don't know if that made it better or worse. But that's what the inverse does. Like if I have x squared equals 36, then the undoing of the square is a square root. So the square root is the inverse of the square. Maybe that was a better way to do it. Okay, so the inverse is the undoing of this something. So basically if I wanted to undo the sine. So the idea is if I do the sine of something is square root of 2 over 2, I want to undo that. So I would do inverse sine on both sides. And that's what that would look like. It would look like theta equals the inverse sine of square root of 2 over 2. Let me erase all this garbage over here. So the idea would be that if you were trying to solve for a problem where you knew what the I don't know, where you knew what the sine value was, but you didn't know what the theta was, then how would you find the theta? Is you would use this pre-written thing. So I'm going to kind of rewrite this a little bit prettier now that I have more space. So how this might come up is you'd have an original problem that would look like sine, come back please, if cherries and stuff. Okay. If I have sine of theta would be equal to the square root of 2 over 2. So then I would take the inverse sine of both sides to undo the sine. So this would be like if I said x squared equals square root of 2 over 2. And then I'd be like, I'm going to take the square root of both sides. That would kind of be the same thing as me saying I'm going to take the doopy-doo. So like if I took the square root of both sides, that's the same thing as me taking the sine inverse of both sides. If that helps. I don't know if that helps. I'm trying. Square root of 2 over 2, like that. So this inverse sine of sine is just whatever's left over, just like the square root of x squared is just the x part, and then that is, who cares? But over here, that has the inverse sine of square root of 2 over 2. Now this by itself I actually think is kind of more confusing. I actually like to look at this one. Eyeballs. That looks creepy. Is basically the sine of what is square root of 2 over 2. And so I just need to look at that. So the sine of what is square root of 2 over 2. So the sine of what is square root of 2 over 2. And the theory is that by now, because you've looked at this for like a whole 15-20 minutes, you would have this memorized at some stage and you'd be like, oh, well, that I just know now happens to be 45 degrees, or pi over 4, because I have those memorized also. Now, this is just in the first quadrant. You did that to me again. First quadrant. There's also answers in other quadrants, but we're only worried about the first quadrant at the moment. Okay, so that's what all of this means. Okay, so now that you kind of have an idea for that, look at the other two and see if you can kind of reverse engineer what's going on there. I'll give you a second, or not really. I bought cowbells on vacation, and I think I was just inspired by cowbells, but now I have them at home, and I'm like, what am I supposed to do with these cowbells? Okay, so now this one. So basically the sine of what, the cosine of what? Cosine of what? Come here. Is 1/2. The answer is the cosine of 60 is 1/2, or pi over 3. And then the question here would be the tangent of what is 1, and the answer is 0 degrees or 0 radians. Kinda, sorta, get there. It comes with practice. The biggest things that you can do right now is really go back to this thingy over here somewhere, is memorize either this page or this page, whatever way makes the most sense to you. Memorize sine, cosine, and tangent of 0, 30, 60, 0, 30, 45, 60, and 90 in the first quadrant only, and that will help you infinitely. If you have some old hippie caught another hippie tripping on acid, and you have 0, 30, 45, 60, 90, a sine, cosine, tangent. I know it seems like so much, and that's all we've been talking about is like memorize this, memorize this, memorize this, memorize this. And it's just because you know how like learning is like a pyramid, and there's like the lowest. So I had this professor who was like, memorization is stupid because knowledge, I can't spell knowledge. They're like, knowledge is the lowest form of learning. And I'm like, it's not the lowest form, idiot. It's the foundation. That's like, the foundation is the lowest part of your house. Well, that is technically true, but it's also kind of super important. So don't neglect this part because you really, 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 really need to know it. So sine, cosine, tangent, memorize definitions, memorize the basic values for the common things and the special triangles and stuff like that. And just kind of get comfortable with it so that whenever you have to do more complicated manipulation with it, you're good to go.